All right, so now we move on to part 2. So here you're gonna use some of the things that we learned in part 1, but let's go ahead and get started. So in 1988, approximately 1.4 million acres, which is 566,560 hectares, in and around the Yellowstone National Park of land was consumed by fire. So 36% of the of the 850,000 hectares of the park were burned during that year. So that's quite a big percentage of just the park, and a lot of it was burned outside the park. So the following images that you'll see, so there's going to be 4 different images, cover basically the same area and cover the area where the Clover Mist fire happened. That fire happened in 1988, but the images are from 1987, 1989, 1998, and 2008. So the first figure, figure 2.1, in the next image is the picture from 1987, before the fires happened. So the grid that you're going to see, and I'll show you in a second, is the tier and range grid used by the Public Land Survey system in the US. So the tier and range system, or actually the Public Land Survey system, helps each state determine, each state has its own, and it helps each state determine where the land is and who it belongs to, basically what it's made out of. And so the tier and ranges are the subdivisions, both on a north-south base and an east-west base. Each of these squares is called a township, and it's 6 miles by 6 miles, so the whole square is 36 miles squared. Okay, let's see. So this whole square is called a township, as I said, and is the basis for the public survey of land in most of the United States. So here you also should note that there are also some half townships on the scene, and there are only 8 that are going to be only 18 square miles. So these half townships happen in the Montana-Wyoming state line. So as you see here, for example, this is the Montana-Wyoming state line. As you see, this is the map, the smaller scale map that is corresponding to this one. And you see that the state line happens right here. And so because, as I said, each state has its own way for the Public Land Survey system, the splitting up of townships just ended up being a little bit messy. So some of these are only half a township. Okay? All right. So we can scroll down further. So that is the first image, which again happened in 1987. What you see in the image is a legend, and the legend says the darker that the squares are, the healthier the vegetation is, meaning the more trees that there are that are not burned. And then the wider that they are means the less healthy the vegetation is, and hence the more burned areas that you have. So this is in 1987, before the fire happened, and this following one is in 1989, so 1 year after the fire happened. So as you see, a lot of it is no vegetation or burned, right? A lot of it is white. You can see that both in Wyoming and in Montana. And what they're asking us is a set of questions based on the amount of area that was burned. So let's jump in for the first question. So estimate the area burned in the image. So show your work by following the steps below. So you need to evaluate the images, mostly this second image, and from that determine how many townships were completely burned, how many townships were 75% burned, how many were 50% burned, and how many were 25% burned. So the easiest way to do that is to print out this image and go ahead and cross out the squares that you have been adding. So for the first one, number of townships that were 100% burned. For example, I would consider pretty much all of these 4 to be 100% burned, maybe even this one. So I would put down 5 right here. And there are some up above too. This one would also be. So maybe 6, 7 even. Would be 100% burned. Then I would look at the ones that were 75% burned. So something that is 75% burned would be something like this, maybe even like this, right? Like this one even. So you write however many you count and you put them here. And make sure that, again, you cross the ones that you already counted, otherwise you're going to count them twice. So you do the same thing for the number of townships that were 50% burned and 25% burned. And then you use this formula B is equal to however, whatever you get for P times whatever you get for Q times 0.75, so on and so forth. Once you have that value of B, you're going to say the area burned is equal to the total townships, or B, right, times the area of the township. So remember that the area of a township is 36 square miles, right? So the total area burned is going to be 36 square miles times whatever you get for B. Excellent. So that's going to be this. And the area burned in hectares is going to be equal to that number that you obtained times 259, because 1 square mile is equal to 259 hectares. So if you had, I don't know, let's just say 100 square miles, you would say 100 times 259, and you get that as, what is that, 25,900 hectares that were burned. Now I don't know exactly what that number is going to be. That's just an example. But that is how you obtain the answer for question number 11. All right. So consider the following scenario for the questions that follow. And here I hint that you are going to use a lot of what we used in part 1, meaning the equations that you used in part 1 in the lettered sections to complete that table. So assume that the area burned, and all of these things are assumptions that you're going to use in order to complete these questions as well. So assume that the area burned in Yellowstone fire was predominantly mature lodgepole pines. So lodgepole pines, first thing, that were 80 years old, second thing. They were 16 meter tall, third thing, and their diameter was 0.61 meters, fourth thing. Cool. Assume that there were 10 trees per every 100th of a hectare, fifth thing. And assume that the entire area burned. The entire tree burned, including the roots, and that all the sequestered carbon dioxide was released into the atmosphere. Okay, so we have like 6 to 7 assumptions, depending on how you count them. Okay, so what was the volume of each tree? So let's look at the same document above. Let me open that. All right, so from the lettered part of part 1, the lettered questions in part 1, we have a few things that we're going to use. One of those is going to be volume, which we were just asked in question 12. So what was the volume of each tree? So we know that volume is going to be, we're going to consider as a cylinder, and we're going to say it's equal to pi times the radius squared times the height of the tree. So we're going to say the volume here is going to be equals to pi times the radius, which the radius is half the diameter, so half of this squared, times the height of the tree. And we know that the height of a tree is 16 meters tall. So volume is equal to pi times half of this squared times 16 meters. Boom, we get the answer for number 12. Question 13. What was the weight in kilograms of each tree? Okay, so the weight we also find using these equations. So remember that the weight is determined by this B value that we had as the oven dry biomass. And that value was obtained using the volume that we just found, the specific gravity, which is depending on each type of tree. So in our case, we have lodgepole pines. So our specific gravity that we use is 0.41, and that times the weight. So our answer for number 13 would be B equals the volume that we obtained in number 12 times 0.41 times 1,000, which is the weight of 1 meter cubed of water. Excellent. So you get answer for number 13. Number 14. What was the total weight in kilograms of each tree, including the roots? So total weight, if you remember from the letter part, was found by multiplying that B answer that we just obtained times 1.2. So number 14 is simply going to be whatever you get for 13 times 1.2. And that's going to be able to determine the weight, including the roots of each tree. Okay. Number 15. What was the total weight in kilograms of all the trees that burned in the fire? So here it starts getting a little bit trickier because we don't know how many trees there were in the fire. We know how many hectares got burned, but we don't know how many trees got burned. However, we do know that how many trees there can be in a hectare. So We know that there are 10 trees in 1/100th of a hectare. So what does that mean? In 1 hectare, we must have, and I'll let you do that calculation on your own. So now we know the area that burned. We know however many hectares burned, right? So if we know how many trees there are in a hectare, we know how many trees also got burned, right? Excellent. So that number of trees that got burned, we multiply times question number 14 of the total weight of each tree, and hence we will know the total weight of all of the trees that got burned in the fire. Good. Okay. Question 16. What was the weight in kilograms of carbon sequestered in the burned trees? Okay. So here is no longer the total weight of the tree, but only the weight of the carbon. So also from the letter part, we know that carbon weight is simply half of the total weight of the tree. So what you would do is take question 15 and divide it into 2 to get question 16 basically. And lastly, question 17. How much carbon dioxide in kilograms was released into the atmosphere in the fire? So remember that the weight of carbon dioxide is 3 times 6663, or sorry, 3.6663 times greater than simply the weight of carbon. So we simply take whatever answer we got for number 16 and multiply it times 3.6663 to get the weight of the carbon dioxide that was released into the atmosphere, since we assume that all of the tree burnt up and it released all of the carbon dioxide that it had originally stored. All right, great. So now that we have finished this part, we can move on to the next bit, which also incorporates the same idea. So figure 2.3 on the next page is of the Clover Mist fire in 1998. That is 10 years after the fire happened. And figure 2.4 on the page after that is the Clover Mist fire in 2008, which is 20 years after the fire happened. So again, the same location, same area, except that now we are seeing the area 10 years after the fire happened, and we are seeing the area here 20 years after the fire happened. So divide and label the legend of the 1998 and 2008 images into 4 equal sections. So same thing that you did before. So basically this is 100%, this is 75%, 50%, 25%. Oh, sorry, the topmost section is going to be the first section, will be 100% healthy. Moving down the legend, second section will be 75% healthy, third section will be 50% healthy, and the last section will be 25% healthy. Completely white indicates that the area is completely burned in 1989, and that there is no vegetation regrowing in 1998 or in 2008. So as of 1998, so the image or figure 2.3, would you estimate that the burned area was 100% healthy, 75% healthy, 50% healthy, or 25% healthy? Or you think it's still completely burned? So basically what I would do if I were you, and using the legend, not necessarily using the comparison, but using the legend and the subdivisions that you made, determine whether those sections that were completely burned in the previous image are now 25% healthy, 50% healthy, 75% healthy, or 100% healthy. So I'll give you this first answer just so that you know kind of what I'm expecting. So for this answer, this first answer on question 18, what I think is that the area that was originally 100% burned is now about 25% healthy, maybe 35, but that's not an option. So it's closer to 25 than to 50. So then my answer for question 18 would be 25% healthy. All right, so question 19. Assuming that the new growth in the forest captured the same percentage of carbon that the burned area released, how much carbon dioxide was sequestered by forest regeneration between 1988 and 1998? So basically what you do here is multiply whatever percentage was healthy in question 18, so I told you it was 25%, times the question you got, or the answer you got for question 17, and there you have it. Question 20 and 21 are very similar, and then the remaining questions I think are pretty self-explanatory and not mathematical, so I think you guys can do them on your own. So I won't cover those in detail here in this lab help video. Alright, good luck. Let me know if you need any help.